Using right triangles to model basically everyday situations here and using a little bit of SohCahToa math. This is a good review though because we're going to be talking about things like angles of elevation or depression. So just as a quick review, recall that when we talk about angles of elevation or depression, they are always measured as up or down rotation from what we call this imaginary horizontal line that's called the horizontal. So this would be our angle of elevation, right? And our angle of depression would be down from the horizontal. And remembering things like angles of elevation and depression are always considered to be positive, no matter what direction rotation. But this idea of elevate or depress just means up or down from the horizontal. So number 5 here says you're looking up to the top of a 500-foot tall tower at an 18.2-degree angle, and I think this would have to be an angle of elevation here. How far from the base of the tower are we? Well, let's go ahead and start by sketching this situation. So I know that, if I had a tall tower, maybe it was here, and I'm standing from the base of it, 18.2 degrees is not very steep, so I'm almost probably drawing this not to scale. It's a little bit too steep there, but 18.2 degrees, and we know that there's a 500-foot height here, so let me put in another 0, so 500 feet. Our job then is to determine how far we are from the base of the tower. Well, if this is us, and being careful to model this correctly here, if here's our tower, right there, then we need to know this distance right here. So which trig ratio would be the most appropriate? Well, it looks like we know our opposite and our adjacent. So let's go ahead and write this out here. Opposite over adjacent, that's our tangent. Tangent of 18.2, and this is in degrees, would be equal to 500 feet over d. And now our job is just algebraically to solve for d. So knowing that when we have a variable down in the denominator like this, we have to multiply that out. We get d tan 18.2 degrees is equal to 500. And here we're just going to divide both sides by our tangent of 18.2. So our d is 500 over the tangent of 18.2 degrees. So at this point, we're just going to get out to two places a decimal on our calculator, and I have to be very, very careful here. It looks like I'm in degrees. Let's go make sure I am actually set in degrees mode. So 500 divided by the tangent of 18.2 degrees here would mean that we're about 150.08 feet. So about 150.08 feet from the base of this tower here. Okay, so number 6, a little bit different. It says an observer in a lighthouse 350 feet above sea level spots a ship directly offshore. The angle of depression to the ship is 6.5 degrees. So how far from the ship? How far is the ship from the lighthouse? Well, in this case, we could draw our lighthouse here, I suppose. If you wanted to imagine, it's this guy right here. The fact is, we have an observer up here that is seeing this ship off in the distance here. And so if we say, here's our ship that is sailing inward towards this lighthouse. Well, the fact is, when you talk about an angle of depression, we have to imagine that this observer has an imaginary horizontal running through their eyes that is totally parallel to the horizontal that is the ground here. So you can understand that this person is looking at this ship over here, and you can kind of see this triangular situation developing. But the fact is, the angle of depression is not this right here. This is not 6.5 degrees inside our triangle. Remember that angles of depression are down from the horizontal. So our 6.5 degrees actually lies on this outside portion of this triangle. So how are we going to find out some inner angles? Well, one way we can do this is we can take 90 minus that 6.5, and that would kind of tell us that this top angle here inside of our triangle is 83.5 degrees. Since this angle of depression and this remaining angle have to make a 90-degree angle with each other, the tower meets the horizontal at 90. And the other way to think about this is just that this imaginary horizontal running through this person's eyes that's parallel to the ground, well, they are parallel, and the hypotenuse of this triangle is kind of like a transversal. So that is to say that if our angle of depression up here is 6.5 degrees, then our angle of elevation from the ship up to the top of the tower is also 6.5 degrees. This kind of gives us some options as to what angles we want to use here, but the bottom line is we just got to be really, really careful how we imagine this. So this is our 6.5 degrees down here. We know that this is a 350 foot tall lighthouse tower, and we're trying to find the distance between these guys here. So in this case, I suppose we could use a tangent ratio. Again, our tangent ratio would be maybe of our 6.5 degree angle down here. We know our opposite over adjacent. So in this case, we could do 350 over d, and kind of a similar tactic to last time. We can multiply the d up and divide the 6.5 or the tangent 6.5 down. We get d is 350 over the tangent of 6.5 degrees. So we'll go and investigate this here. 350 divided by the tangent of 6 6.5 degrees is about 3071.91. So about 3071.91, and this was in feet. Just to go to show that we didn't have to use this angle of elevation or depression at 6.5, we could have used this top angle here, or this elevated angle. I shouldn't say that. This angle at the top of the triangle, and done another tangent ratio. We know our opposite over adjacent here. I actually feel like this might have been a little bit more convenient because the algebra, the tangent of 83.5 becomes d over 350. In this case here, we just simply need to multiply the 350 up. So we get our d is 350 tangent of 83.5. And I just want to go to show you here on the calculator, what would we get if we did that? Well, we'd do 350 tangent of 83.5, and we would get the same measurement here. So it's kind of just dependent on which one you want to use. Make sure you're setting it up right is what I'm most concerned about. Cheers.